Okay, this lesson is going to still continue in the idea of solving equations. We're just going to look at some different types of equations. So one of the ones we're going to focus on here is ratios and proportions. Now, one thing to note, the difference, a ratio is nothing more than a fraction. Okay, that's all that means. Proportion are two fractions that are set equal. Okay, so this fraction is considered a ratio. This whole thing, equation, is referred to as a proportion because it's two fractions that are set equal. Okay, so it's still an equation, it's just a type of equation, a special name called a proportion. Okay, so what we're going to do is we're going to come down to the year term problem number 3, and we are going to try to work that one together. It says a scale model of a human heart is 196 inches long. The scale is 32 to 1. Okay, how many inches long is the actual heart? Okay, so one of the things you want to do when you write down your scale is nothing more than a ratio or a fraction. Sometimes they use the word to. Sometimes you'll see this a lot of times on models or scale models of boxes of like cars and things that you build in stores and that sort of thing. But the way we're going to do it is writing as a fraction. So I'm going to write it as 32 over 1. Now, when I do this, the 32 is the actual size. Okay, it's the big size. The 1 is the scale model or the small size. So some people put large over small. Now, again, it doesn't matter how you write this fraction. I could write it as 1 over 32. What matters is when I set up my proportion, okay? It says the scale model is 196 inches long, okay? So that's the scale. That is the small. So what that means is when I write my other fraction, it has to go where small is. So 196 has to go on bottom. What I'm looking for is how long is the actual size, which means my x has to go on top. So again, what could have happened is if I'd flipped my scale here, so if I'd flipped these and put 1 over 32, then my equation would have looked like this. 1 over 32 equals 196 over x. So what matters is that these go together, okay? Those are what match up, so they're in the same spot. What you can't do is flip them around, okay? Then, how do you solve? So this should be something you guys are familiar with. It's called cross multiply. So 1 times x is x, and then I do 32 times 196. So 32 times 196 is 6,272. So 1x equals 32 times 196, which is 6,272. Look at your units, inches. So that's the actual, okay, actual size of the heart. Let's continue on. There's this other thing called dimensional analysis. Okay, all that means is what a lot of people refer to it is rate conversions. Okay, rate conversions. In chemistry, it's referred to as factor labeling. Now, it's a very, very important skill in chemistry, so it's good that we're addressing it here. You're also going to see it sprinkled in some of the different modules and problems that we do, because what's going to happen, they're not in the same units. So all it is, it's taking one unit and changing it to another one. Now, sometimes this can be difficult because you don't know what conversions are. Like we know 12 inches in a foot, but like down here, we're going to do this year term problem. It says, how many feet are in meters? Well, I have no idea. So what you may have to do sometimes is look some stuff up on the computer. But I'm going to start with this number 4, seconds to hours. So I'm going to bring it right down here. So what I have is 7,500 seconds. And we're going to use the principle of proportions. This is really over 1. Now, what I'm going to do is I'm going to write another fraction here. What I'm trying to do is change my seconds to hours. So I want to get rid of these seconds. Well, if I have something on top, to get rid of it, I have to put it on the bottom. Okay? Now, the first rate conversion I would do is 60 seconds. 60 seconds because there's 60 seconds in what? 1 minute. Now, what's going to happen? The seconds here are going to cancel. But then I got to change minutes to hours. So my minutes is on top, so I need minutes on the bottom. How many minutes are in an hour? There's 60 minutes in 1 hour. So what happens to the minutes? They cancel. So now I'm left with the unit of hours. Now, how do I do this problem? All I do is I multiply everything on top together. So that's going to give me 7,500. Multiply on the bottom together. 60 times 60 is 3,600. Then I just divide that on the calculator. It says round to the nearest tenth. That's 1 decimal place. So I do 7,500 divided by 3,600. And I get 2.1. And my units were hours. So I come up here. And then I just write 2.1. Okay, let's do number 6. Because this is another one that's relatively, I won't say easy, but something that you're probably more familiar with, okay? So I'm going to erase all this right here. See if I can do this a little bit faster. No. Okay. So, let's get rid of our error. So in this one, I have 4 inches. I want to change it to yards. So the first thing I'm going to do is get rid of my inches. What's the easiest conversion I know? Inches to feet. There are 12 inches in 1 foot. There go my inches. Now I need to change feet to yard. Now hopefully you know this one, but you may not. But got to get rid of my feet. There are 3 feet in 1 yard. Football players should know that one. So now I'm left with yards. Now I'll multiply my top numbers. 4 times 1 times 1 is 4. Multiply my bottom. 12 times 3 is 36. Divide that on the calculator. 4 divided by 36 is 0.1. So I get 0.1 then yards. Okay, so now what we're going to do is, erase. We are going to get rid of, erase the 0.1 too, I didn't want to do that. We're going to change the feet to meters. Now this is a little bit harder, so what you may have to do is look this up on the computer. So what it tells me is that 1 meter equals 3.28084 feet. Okay, now, again, when I set up I start with 3 feet. I want to get rid of my feet. So that means feet needs to go on the bottom. So this 3.28084 feet go here, and that is 1 meter. So now my feet cancel. I'm left with meter. So that's going to give me 3 over that big decimal number, 3.2, blah, blah, blah. So I divide that on the calculator, 3 divided by 3.28084, and I get 0.9. So that would be 0.9. Sorry. Can't get my pen to work. Here we go. 0.9 meters. So that's rate conversion. All right, as we continue on here, we also have these word problems that are very similar to what we just did. The difference is we're going to do a comparison here, but they're in different units. So what we got to do is we got to get everything in the same unit. So we've got Alan here, who is 1,750 feet per. Whenever we see per, that's a fraction. We're going to talk about per as a rate later on and equate that to slope. So let me say this again. The word per is rate and slope. We're going to deal with that quite a bit. Okay, but 1,750 feet per minute. And then we have Barry here, who is 21 miles per hour. So I've got to change one to either, I got to change Barry to feet per minute or Allen to miles per hour. It doesn't matter which you do, but all you're trying to do here is convert them. It says, whose go-kart travels faster, round your answers to the nearest tenth, which I'm not really sure why you're rounding answers because it doesn't really matter. But what I'm going to do is I'm going to change Allen, okay? Now, this time we've got to change 2 units because I've got to change my feet on top, but I've got to change my minutes on bottom to hours, okay? So first I'm going to deal with my minutes. What do I know? Well, if I'm getting rid of minutes, I need minutes on the top. There's 60 minutes in 1 hour. Oops. Now, what that's going to do is get rid of my minutes. That's going to leave hours on the bottom, just like it is right here. Then I've got to get rid of my feet. So again, what you may have to do is look on the computer and see what the conversion is, okay? But for feet to miles, and you may remember this from Remember the Titans. I don't know if you've ever watched that movie, but there are 5,280 feet in 1 mile. So now my feet are gone, top and bottom, and I'm left with miles. So now I have miles per hour, just like I do right up here. Now I do my numbers, multiply everything on top together. So I do 1750 times 60 times 1. Then I'm going to divide that by, that's just going to be 5,280 since it's times 1. And I get 19.9 miles per hour. And that's Allen, so that means Barry is going faster. He's going 21 miles an hour. All right, so it continues on, proportionality with doing graphs. And you notice they just plot points, so hopefully you can plot points here and do that. So we're going to do just one of these. We're not going to do both. We're just going to do one of these here. One of the other things you want to do is you want to learn how to do a scale and label your axis, okay? So I'm going to do number 10 here, okay? It says Alex drove 135 miles in 3 hours. So 135 miles in 3 hours. So I'm going to simplify that. So one of the things you want to learn to use here on the calculator is your fraction button. So what do? You press alpha, y equals, and then there's this little menu. You want to pick the number 1, n over d, and you type 135, right arrow to get on the bottom, 3. Press that and it simplifies it for you, which would be 45 miles per hour. Now, we talked about rate being a slope. This is a rate or speed. This is also slope. Slope is rise over run. Rise is your y. I think of slope as change in y over change in x. Now, the reason this is important is because it tells me my y axis must be my miles. So when I'm labeling my graph over here, I'm going to come over here and I'm going to label this as miles. My x in turn is my hours. So I might call my y-axis distance, but then I have to put units with it in miles. My x-axis I'm going to call time, and it's in hours. Then what I'm going to do is decide my units. Now my hours I'm going to go by ones. So it starts 1, 2, 3, 4, 5, 6. Okay. Now how do I do my y? Well, this is per 1 hour. How far do I go? 45 miles. So for my y-axis, the scale I'm going to use is 45. So on my y-axis, I'm going to go 45. That's not very good. Let me see if I can do a little bit better writing that here. Make it a little bit cleaner. So the first one would be 45. That's still not very good. The next one would be 90. So I'm going to draw a little arrow here. This would be 90 because 45 times 2 is 90. The next one would be 135. That's really hard for me to write in here because it's such a small area, but hopefully you get the idea. You just keep going up by 45 each time. So the next one would be 180, and you label all those. Okay? Then what you're going to do is plot your points. After 1 hour, I go 45 miles. After 2 hours, I go 90. And it makes it real easy to graph because I'm landing on these exact points. And the reason that is because I chose my scale for my y-axis to be what my slope was. Now that doesn't always work out real easy, but you can try to do that. So hopefully this has made sense. I know this is kind of a long video, but a lot of different things in here you want to make sure you know.